Happy morning, students. I welcome to all today's session. Tomorrow you are all going to write chemistry test. We have two lessons, thermodynamics and periodic classification. The pattern is choose the correct answer 5, 2 marks 4, 3 marks 4 and 2 5 marks, so total 35 marks. So in this class we are going to concentrate 2 marks and 3 marks in self-evaluation part. So we have lot of 5 marks, 3 marks, 2 marks in each lesson. So you go through all the self-evaluation parts. So prepare well for your exam. Kindly go through all the question and answer and do your exam well. All the best, students. Okay, let us start now. First question, define modern periodic law. The modern periodic law states that the physical and chemical properties of the elements are the periodic functions of the atomic number. So the physical and chemical properties of the elements, periodically the functions are repeated of the atomic numbers. Then second question, what are isoelectronic ions? Give example. Isoelectronic means the atoms of different elements, that is ions of different elements having the same number of electrons. Same number of electrons are called isoelectronic ions. So ions of different elements, here the sodium, magnesium, aluminum, fluorine, oxygen, nitrogen. So number of electron, we know the atomic number of sodium is 11, so it loss of 1 electrons, so it is carrying Na plus, so the number of electrons, that is 10. Then magnesium, we know the atomic number of magnesium 12, so it loss of 2 electrons loss, so the outermost valence is the 2 electrons loss, is getting the plus 2, so it is getting the 10. Then aluminum, we know the atomic number of aluminum 13, so 3 electrons loss of 3 electrons, so here they are getting aluminum 10. The fluorine 9, so it getting 10. Then oxygen, we know 8 the atomic number, the 2 minus means the 2 electrons are had, then 10. The nitrogen, we know the atomic number is 7, here the 3 minus, so 7 plus 3 10. So this is a isoelectronic ions. Okay. The next, what is effective nuclear charge? The net nuclear charge experienced by the valence electron in the outermost shell. Valence electron in the outermost shell is called as a effective nuclear charge. So where Z is a, here the Z is a atomic number, S is a screening constant. Okay, the outermost shell. For example, the lithium, the atomic number of lithium is 3, 1s2, 2s1. So the outermost shell is a 1. Then sodium, the atomic number 11, 1s2, 2s2, 2p6, then 3s1. Okay, so the outermost shell is called this effective nuclear charge. The formula is Z effective equal to Z minus S. S is a screening constant, Z is a atomic number. Then third question, is the definition given below for ionization enthalpy correct? That is, ionization enthalpy is defined the energy required to remove most loosely bound electron from the valency shell of the atom. So this definition is incorrect, because the correct explanation for the ionization enthalpy is that is defined the minimum amount. Ionization energy means energy it is required. So the minimum amount of energy required to remove the most loosely bound electron from the valence shell of the isolated neutral gaseous atom in the ground state. That is, this is a metal. The metal, that is the atom, is not a metal, the atom it requires the energy to remove the electrons. So it getting the Ma plus electron. So it getting the energy, the minimum amount of energy to require to remove an electron mostly bound of electron from the valence shell of the isolated neutral gaseous atom in the ground state. This is a correct definition for the ionization enthalpy. Then third one, magnesium loses electrons successively to form Mg plus, Mg2 plus and Mg3 plus, which is represents the highest ionization energy. Why? So the first equation is Mg first ionization energy getting Mg plus, here the 1 electrons removed. Then second Mg plus second ionization energy gives Mg2 plus. Then third Mg2 plus ionization energy, then Mg3 plus 1 electron. Here which is highest ionization energy means Mg2 plus ion having the stable inert gas configuration. Mg2 plus means the atomic number for the Mg. The atomic number is a magnesium. The atomic number is a 12. So here the 2 electron, getting the 2 plus means here the electronic configuration 1s2, 2s2, 2p6, 3s2. So the 3s2 2 electrons remove means it getting the Mg2 plus. So it attained the noble gas configuration for the neon. The neon electronic configuration is 10, 1s2, 2s2, 2p6. Okay. So the second one, the Mg2 plus ion having the stable neon inert gas configuration, it requires more energy to lose 1 electron forming Mg3 plus. So Mg2 plus attain the stable electronic configuration similar to the noble gas. Noble gas is a stable form, so it can be remove 1 electron is a it requires more energy to lose 1 electron from to forming Mg3 plus. So third step will have the highest ionization energy. So the ionization energy is third step will have the highest ionization energy. Okay, or Mg2 plus consists of 10 electron, 2, 8 attaining the stable configuration neon. So Z equal to 10. Okay, then third one, define electronegativity. What is the electronegativity? Electronegativity means the covalently but the molecule to share the share pair of attract electrons towards itself. That is electronegativity. That is, it is defined the relative tendency of element present covalently bonded molecule to attract the shared pair of electron towards itself. That is called as a electronegativity. Okay, the next. How will you explain the fact the second ionization potential is always higher than the ionization potential? Okay, then ionization, highest ionization energy. Why? Then the 30th question. Second ionization potential is always higher than the first ionization. The total number of electrons less in the cation than the neutral atom, while the nuclear charge remains the same. Therefore, the effective nuclear charge of cation is higher than the corresponding neutral atom. So, the successive ionization energy always increase the following order: ionization energy 1, ionization energy 3. The next question, the energy of electron is the ground state of the hydrogen atom 2.18 10 power 18 joule. Calculate the ionization enthalpy of atomic hydrogen in the terms of kilojoules mole. So we can substitute the ionization formula. So the ionization energy per hydrogen atom and ionization energy per mole of hydrogen atom. So we get a plus 1311 kilojoule mole. Okay. So the next question is what period and group will element with Z equal to 108 will be present? So the answer is 118 means the 7th period and the group is the 18th group. So the explanation is that the atomic number 118 means the electronic configuration radon 5f14 6sd 7s2 7p6. So in the periodic table the element is at 118 is located in the p block element, the period number 7. So as the n equal to 7 valence shell. So group number is 18, group number 10 plus ns electron plus np electron, the n is the outermost shell. Okay. The next, justify that the 5th period of the periodic table should have 18 elements on the basis of the quantum number. According to the Offer principle, the 5th period has a 9 orbital. The 9 orbital means 1 5s, 5 4d and 3 6p. So the 1 plus 5 6, 6 plus 3 9. So that to be filled. Okay. The 9 orbitals can accommodate the maximum 18 electron. The 5th period of the periodic table should contain 18 elements with the rubidium to xenon. So this is the answer for the question. The next, elements A, B, C, D are the following electronic configuration: 1s2, 2s2, 2p6. A, B is a 1s2, 2s2, 2p6, 3s2, 3p1. Then C, 1s2, 2s2, 2p6, 3s2, 3p6, 1s2, 2s2, 2p1. Which group of element will belong to the same group of the periodic table? the element A and C, that is the element A and C belongs to the group 18. The element B and D belongs to the group 13th, which is a group 13. Group 13 means, what is a group 13? The boron family, boron, aluminium. Okay. Then group 18 means, group 18 means the noble gases. Okay. Noble gas means helium, neon, argon, krypton, xenon. 1s2, 2s2, 2p6 is a neon. Okay. It's a noble gases. Okay. The next question. The next question, we write the electronic configuration of lanthanide and actinides. So lanthanide means, we know the lanthanides, the xenon, the noble gas configuration xenon 54, it is 4f black elements, so 4f totally 14 element, 1 to 14, 5d 0 to 1, then 6s2. This is the electronic configuration of lanthanide. Then actinides is a radon, so radon 86, 5f, so totally 0 to 14, then 60, 0 to 2, then 7s2. This is the electronic configuration of lanthanide and the actinides, that is the F block elements. Okay, these two are F block elements. The next question, why halogen act as a oxidizing agent? Due to low bond dissociation enthalpy, the high electronegativity, a large negative electron gain enthalpy, halogens have a strong tendency to accept electron and get reduced x2 plus 2 electron get it 2x minus. So the readily accept of electron, that is the fluorine, the atomic number of fluorine is a 9. So 9 means the first shell contain 2 electrons, then the next shell contain the how many electrons? So 2, then remaining 7. Okay, so 7. He listen. So it readily available to gain of the electrons, to accept of the electrons. So it acts as a strong oxidizing agent. So F2, the compared to the halogen family, the fluorine is the strongest oxidizing agent of halogen, oxidized to the halide ion in solution, even the solid phase. Okay, the next, mention any two anomalous properties of the second period element. Anomalous properties second period element, lithium and beryllium are more covalent compound, unlike the alkali and alkaline earth metals predominantly form ionic compounds. The element of the second period have only the 4 orbital, that is 2s and 2p in the valence shell. Our maximum covalence is a 4, whereas other member of the subsequent periods have more orbital, valence shell shows the higher valence. For example, boron forms boron tetrafluoride, the aluminum from AlF6 3 minus. Okay, the next question is, explain Pauling method for the determination of the ionic radius. So what is the ionic radius? We know the definition, the distance from the center of the nucleus which exerts the influence of the electron cloud of the ion. So ionic radius of univalent crystal can be calculated Pauling method. So the interionic nuclear distance between the nucleus of the cation and the anion. Example for that, NaF, KCl or BBr, that is rubidium bromine, then CSI. Pauling assume that ion present crystal lattice perfect here, they are contact to each other. So D equal to Rc plus Ra minus, this is equation number 1. So where D is the distance between center of the nucleus of the cation and the anion. Then R is represent radius of the, Rc is represent radius of the cation, and Ra minus represent radius of the anion. Now the Pauling also assume the radius of the ion having noble electronic configuration is inversely proportional to the effective nuclear charge. So radius of cation is inversely proportional to the effective nuclear charge. This is the equation number 2. Then radius of anions is inversely proportional to the effective nuclear charge of the A minus. Now the effective nuclear charge, so divided by the equation 2 and 3. Equation 2 divided by 3. So we get Rc plus anion, then Ra minus cation. Okay. The next question, explain the periodic tensor of ionization potential. The energy required to remove the most loosely held electron from isolated gaseous atom is called as a ionization potential. In period wise, as the increase along a period, then you increase the nuclear charge, that decrease the size from left to move from left to right. In group wise, as we move down the group, the ionization energy decreases, the gradually increase in atomic size. Okay, the next one, explain the diagonal relationship. The diagonal relationship means this is a diagonal relationship. This is a first group, lithium, beryllium, boron, carbon, this is a first group. Then sodium, magnesium, aluminum, silicon. The diagonal relationship means this is a diagonal relationship. Are moving diagonal across the period table second and third show the certain similarity. This is a diagonal relationship between the second and the third. Okay. The next, why ionization enthalpy of sodium is lower than that of magnesium, while the second ionization enthalpy is higher than that of magnesium. The electronic configuration of sodium 11, write the electronic configuration 1s2, 2s2, 2p6, 3s1, magnesium 12, so 3s2. The magnesium atom is a smaller radius but has a higher nuclear charge than the sodium atom. So the more energy will be required to remove electron from the same orbit of the 3s, making the first ionization energy of magnesium higher than that of the sodium. The second ionization energy compared to the sodium is higher than that of the magnesium. This is because the after losing one electron, the sodium attains stable electronic, that is a stable noble gas configuration neon. Other hand, the magnesium as an electron, after losing one electron, still has one electron in the 3s orbital. Okay, that is for second ionization enthalpy of sodium is higher than that of the magnesium. The atomic number of sodium we know 11, then magnesium is 12. So the Na plus getting means here lose of one electron, here 2 plus getting means it lose of 2 electron. Okay, so the second electron, the required energy to remove the second electron is the case of sodium is much higher than the required the case of magnesium. So sodium is higher than that of magnesium, the ionization energy. Okay, the next question, what is screening effect? The screening effect means the repulsive force between inner shell electron and the valence shell electrons leads to decrease the electrostatic attractive force acting the valence shell electron by the nucleus. That is, the inner shell electron acts as a shield between the nucleus and the valence shell. This is the example for that. So the lithium, the inner shell is containing 2 electrons, the outer shell containing the 1 electron. So the inner shell electron acts as a shield between the nucleus and the valence. This effect is called as a shielding effect or screening effect. Shielding effect or screening effect. The next question is state the terms variation of electronegativity to group and period. Electronegativity in a period means the electron generally increase across a period, then atomic radius decrease in period, the tendency to attract share pair of electron increases in a period wise. Group wise, as we move down the group decreases, electronegativity decreases as move down the group, the atomic radius is increases, nuclear attractive force are decreases. Okay. Then one more lesson is thermodynamics. Students, please go through all the self-evaluation part in this lesson thoroughly. Kindly go through all the question and answer for 2 lessons. Get good marks. All the best, students. Thank you.